tanong,
ba't ganito? Ba't ganon?
hayaang buksan ang isipan.
Sa science o agham, tayo na sa sinueskwela. Tuklasin natin ang siyensya.
Buksan ang pag-iisip,
Tayo'y likas na scientist. Tayo na sa sinueskwela. Tuklasin natin ang siyensya. Kinabukasan ng ating bayan, siguradong makakamtan.
Tomorrow will be the passing of our assignments. But still, now it doesn't have the answer. What will I do? I couldn't measure the mass of this apple. Oh, wait. What if I'll browse the net? Ano? It's book. Wait. Apple measuring the mass. Apple. Okay. Wait. This ruler. It's not a good idea. Oh. What if... Okay. I'll call Jamie. Jamie, please answer the phone. Jamie. Ooh, answer it, please. Hello? Hello, Jamie? Where are you now? Because I have this problem and I know na you can help. I know you can help me regarding to this problem. Would you mind to come here right now, please? Please, Jamie, help me, please. Okay, you'll be here after 2 minutes. I'll wait for you, Miss Mom. Okay, thank you. Bye-bye. See you.
Hey, Perlin.
Hello.
What's your problem?
Wait. Sorry for the mess. Huh?
It's okay.
Take a sit here. Because you know Mr. Sarasa?
Yes, I know.
Okay, he is our professor in physics and he gave me this assignment about how can I measure the mass of this apple without using any weighing scale. And I have browsed the net, I have read all of these books, but I doesn't get the answer. Can you help me?
I think Margaret and Talen know about that. They have an ideas about that.
Sure?
Let's try to ask them.
Thank you. It's open. Hello.
Hello.
assignment about Archimedes principle, and that principle will help your problem.
Archimedes principle. I think I heard that. You know what? We have an assignment like that before. And what we do is that we also conduct an activity to answer that problem. And yes, it works. So why don't we just try that activity for us to answer the problem? Okay, if that would answer my problem, let's try it now.
There are two methods in finding the mass of the apple. The first one is to find the volume of the part of the block of wood that is submerged on the water. The second method is to find the mass of the water displaced in the glass of water. Do the demo. The first method. Find the length, the width, the height of the part of the block of wood that is submerged on the water. Then, do the math.
A pleasant day, everyone. To know the average mass of the apple, we need to find the dimensions of the block of wood that is submerged on the water. This is the part that is submerged on the water from this figure. So first, find the length. Second, find the width. And third, find the height. The height is the part that is submerged on the water. So the length of the block of wood is 180 centimeters. The width of the block of wood is 90 centimeters. The height of the block of wood is 9 centimeters. To find the volume of the block, we have the formula. Volume is equal to length times width times height. By substitution, 180 centimeter times 90 centimeter times 9 centimeters. It is equal to, so we need a calculator. And this is the calculator. And the volume of the block of wood is 145,800 centimeters cubed. Next, what? We need to find the density of the water. The density of water is 1 gram per centimeter cubed. So, to find the mass of the apple, we have to find the mass of it in kilograms. Disregard the centimeter cube. It is equal to 145,800 grams. So, the weight or the mass of the apple is 145,800 grams. 0.8 kilograms. And it is approximately 146 kilograms. That is the mass of the apple. That's all. Thank you.
We may observe for any immersed object that the volume of the submerged portion equals the volume of fluid it displaces. Second demo. Here are the things we need: the apple, the block of wood, the container with water, the straw in the hole, and the empty glass. First step, put the apple on the top of the block of wood. Just be careful. Second step, observe the water that is flowing in the straw. That is what you call the water displace. Wait until it stops.
Now I know. Hello, friends. Hi. So, Bernie, I'm so happy right now because I have an assignment in physics now. Mr. Zarasa had given to me, and for that, thank you so much, guys. Thank you.
You know what? I know the story about the Archimedes principle.
Archimedes principle. Tell us that right now.
Fine. Listen.
A long time ago, a Greek scientist named Archimedes discovered an important scientific law related to buoyancy. It can be expressed as any object wholly or partially immersed in a fluid is buoyed up by a force equal to the weight of the fluid displaced by the object.
One day, Archimedes was summoned by the king of Sicily to investigate if he had been cheated by a goldsmith. The king said he had given a goldsmith the exact amount of gold needed to make a crown. However, when the crown was ready, the king suspected that the goldsmith cheated and slipped some silver into the crown, keeping some of the gold for himself. The king asked Archimedes to solve the problem, but there was a catch. He couldn't do any damage to the crown. One day, while taking his bath, Archimedes noticed that the water level in the bathtub rose and overflowed as he immersed himself into the tub. He suddenly realized that how much water was displaced depended on how much of his body was immersed. This discovery excited him so much that he jumped out of the tub and ran through the streets naked, shouting, "Eureka!" which comes from the ancient Greek meaning, "I found it!" What did he find? Well, he found a way to solve the king's problem. You see, Archimedes needed to check the crown's density to see if it was the same as the density of pure gold. Density is a measure of an object's mass divided by its volume. Pure gold is very dense, while silver is less dense. So if there was silver in the crown, it would be less dense than if it were made of pure gold. But no matter what it was made of, the crown would be the same shape, which means the same volume. So if Archimedes could measure the mass of the crown first, and then measure its volume, he could find out how dense it was. But it is not easy to measure a crown's volume. It has an irregular shape that's different from a simple box or ball. You can't measure its sides and multiply like you might for other shapes. The solution, Archimedes realized, was to give the crown a bath. By placing it in water and seeing how much water was displaced, he could measure the volume. Then he'd calculate the density of the crown. If the crown was less dense than pure gold, then the goldsmith most definitely cheated the king. When Archimedes went back to the king and did his test, the story says, he found that the goldsmith had indeed cheated the king and slipped some silver in. These days, using the way an object displaces water to measure volume is called Archimedes' principle. The next time you take a bath, you can see Archimedes' principle in action. And maybe you'll have a genius idea of your own.
Now, we learned Archimedes' principle is very important to the field of science.
Without the Archimedes principle, the concept in floating the ship, swimming and sinking in the water will not be discovered.
Therefore, Archimedes discovered an important scientific law related to the buoyancy.
In generalization, Archimedes' principle states that any object that is fully or partially immersed in the water is buoyed upon by a force that is equal to the weight of the water displaced by the object. And lastly, in application, it is used by architects and engineers to make ships, submarines, and other floating structures. So thank you so much guys for watching our video. We hope that you've learned a lot of things from us.
Thank you and God bless.
Eureka!
Hey, hello. I'm fine.
About that activity.